Alright, let's take a look at graphing radical functions. So my best advice to you is, if possible, get these notes printed out and kind of follow along as we would during class. So what I write, you write, and that way you're kind of building your own note packet as we go. I'm going to talk through this. Understand that if there's something that doesn't make sense, you can go ahead and rewind the video, pause it, take a second, think it through. But just, do your best, and please reach out to me if you have any questions. So let's start at the top of the page here. Our warm-up, we want to graph the square root of x using these values, 0, 1, 4, and 9. Those are really important values. We're going to use those throughout this unit. So I'm going to make my table here over on the left. There's my x, my y. My x values are going to be 0, 1, 4, and 9. Remember, we like those four numbers because they are perfect squares. I know that the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. If I go to my graph, I know that the point 0, 0 is on my graph, the point 1, 1, the point 4, 2, and the point 9, 3. It's a little bit off our graph. We'll do our best. And our graph looks something like that. So the other part of this, remember our domain and range. Our domain represents all our values of x, and in this case it starts here and goes to the right. So our domain here must be x is greater than or equal to 0. Our range starts here and goes up. So our range here will be y is greater than or equal to 0. Let's keep moving through this. The inverse of x squared, remember, whenever we take the square root, we end up with a plus or minus the square root of x. Okay, that is not actually a function. If we were to graph plus or minus the square root of x, it would look like a sideways parabola, and it would fail the vertical line test. So, in order to avoid that, we restrict the domain such that x must be greater than or equal to 0. That allows us to create the square root function we graphed just above. The next section here should seem really familiar to us. This should remind us of our transformations unit earlier in the year. Graphs of radical functions can be transformed using the same tools we've used all year long, right? Our A values, our stretch, vertical stretch. Our B value, horizontal compression or stretch. H is inside the radical. That's going to move us left and right. K is outside the radical. That'll move us up and down. All our same rules apply, right? Inside moves us left and right. Outside moves us up and down. Let's look at a couple of examples together. So let's look at example A here. And what we want to do, we want to state the transformations, the domain, and range. I usually save the domain and range for last. I think it's easier to see once we have a graph. So there's a couple ways we can approach this. I know that I want what's in my square root to be a perfect square. So when I set up my table, I'm going to set this up so that 0, 1, 4, and 9 are always inside my radical. Now, because we're not doing anything to x, we don't need to change anything. So once I plug in 0 for x, I get 0. Then I subtract 3. Negative 3 will be my output. When I plug in 1, I get 1 minus 2. That's negative 2. When I plug in 4, I get 2 minus 3, negative 1. And then 9 is the square root of 9 is 3, minus 3 is 0. So if I go over to my graph here, I'm going to plot these points. It's going to be 0, negative 3. Oh, sorry about that. 0, negative 3. 1, negative 2. 4, negative 1. And 9, 0. So I've gone ahead and graphed this. So what are my transformations? Well, I've moved down 3 units. My domain are my x values that are possible. my domain here is that x must be greater than or equal to 0. And my range is that y must be greater than or equal to -3. Pay attention to this point here. This point specifically is the point 0, -3. And that defines our domain and range, right? This 0 here defines our domain, right? The x value of our vertex. And this -3, the y value of my vertex, defines my range. Let's look at a more complicated example. We know how math works. Things feel easy, then they get more complicated. So here I have a couple transformations I have to deal with. I have this 2 on the outside, and I have this +4 on the inside. Now maybe I remember my transformations. I know that that 2 is going to be a vertical stretch by 2. And that 4 is going to be a shift left 4 units. So we can approach that kind of visually, and we can think about what happens to my graph. My graph used to start at 0, now it's moving to the left 4. Well, if I think about 4 units to the left of 0, we can say that our initial input will be -4. Why does that make sense? Well, if I were to plug in -4 for x, inside the radical would end up being 0. Although we like that because perfect squares are easy to work with. The next input I'm going to use is going to be -3, because if I plug in -3 for x, I get 1 as the value inside my radical, and that's a perfect square. That'll be 1. My next input, I want it to be equal to 4 inside the radical, so I'm going to plug in 0 for x. And finally, I want my last point here to be 5. Why is it 5? Because 5 plus 4 equals 9, and that's a perfect square. Now we need to evaluate. So just take your time with this. When I plug in -4, I will get 0 for y. 0 times 2 is still 0. When I plug in -3, I get 2 times 1, which is 2. When I plug in 0, I get 2 times 2, which is 4. And when I plug in 5, I get 2 times 3, which is 6. Hopefully as you go, you kind of see these patterns. You know, right, 2, 4, 0, 2, 4, 6. So let's go ahead and plot those points. -4, 0 is right there. -3, 2 is there. 0, 4 is there. And 5, 6 falls there. And let's go ahead and draw our arrows in there. The last thing we need to worry about is domain and range. My domain here depends on my vertex. X is going to be greater than or equal to 0. And my range, y must be greater than or equal to 0. I made a mistake. Sorry about that. Our domain here should be x is greater than or equal to -4. We're going to look at 2 more quick graphs, and then we're almost through this. We have to deal with our negative sign. So on example C, on the second page of your notes, we see we have a negative sign inside the radical. What that's going to do for us is going to be a horizontal reflection. Okay? Let's get my pen out. Horizontal reflection. That's going to move us, instead of going to the right, we're now going to be having a graph that opens to the left. So again, I want to focus on those 4 key values, 0, 1, 4, 9. And what I'm going to plug in here, well, 0 is still okay, -0 is still 0. Now I want to plug in values that give me a 1, 4, 9 in my radical. If x is negative, I need to plug in -1 to make it positive. I need to plug in -4 to make it positive. I need to plug in -9. When I plug in those values, I'm going to get 0 plus 2, 1 plus 2, which is 3, 2 plus 2, which is 4, and 3 plus 2, which is 5. Now I have my 4 key points, so I'm going to have the point 0, 2, the point -1, 3, negative 4, 4, and negative 9, 5. Let's go ahead and connect this. Be careful. We also moved up 2 units as part of our transformations. Our domain and range here, we just have to be careful with. Our domain no longer goes to the right, it now goes to the left. So x is now less than or equal to 0. And our range is that y is greater than or equal to 2. Let's scroll over to example D for the last one here. We have 2 transformations we have to deal with. Our first transformation is this negative on the outside. That's going to be a vertical reflection. That's going to move us up and down. I know that anything outside the square root moves me up and down. That's what this negative here will do. The 2 inside, this is kind of our most complicated, frustrating transformation. Remember, whenever we're inside, we can never believe what we see. It looks like we're multiplying by 2. That creates a horizontal compression by the reciprocal of 2. So it's going to be by 1/2. So I'm going to set up my table, my x and y values. Now I want what's inside my radical to equal 0, 1, 4, and 9. Those are my key values I'm always searching for when I'm graphing a radical. 0 is going to be the easy one here. 0 times 0, multiply by 2, make it negative, still 0. If I want 1 as a result, I need to plug in 1/2 for x. When I plug in 1/2 for x, I get the square root of 1, which is 1, make it negative, and I get negative 1 out. My next x value, I'm thinking 0, 1, 4, 9. I'm trying to create 4 inside the radical. So 2 times what is 4? Well, 2 times 2 is 4. When I plug in 2 for x, I get the square root of 4, which is 2, and then make it negative, I get negative 2. Finally, I want 9 as my next input, so I'm going to plug in 9/2 as my x value. It's 4.5, and as a result, I will get negative 3. Just be careful with your table here. We're going to have the points 0, 0, the points 1/2, negative 1, 2, negative 2, and 4.5, negative 3. Our domain here will be x is greater than or equal to 0, and our range is that y is less than or equal to 0. It's less than because now we are moving in the downward direction. We're almost through this. Let's take a look at creating examples, creating functions from descriptions. So we're going to walk through A, B, and C here. I know that I'm going to have a square root. All right. I know that I want to stretch it vertically by 5 and translate it 11 units to the right. Well, if I want to stretch vertically by a factor of 5, that's going to happen outside. So I'm going to multiply by 5. And if I want to move right 11 units, I'm going to make x inside the radical. Everything happens opposite. So it's going to be x minus 11. Looking at example B, if I want to reflect over the y-axis, that's a horizontal move. That means that my x inside the radical must be negative. And if I want to move down 20 units, I'm going to make a minus 20 outside the radical. Finally, let's look at a horizontal stretch of 6. I know that everything's backwards when I'm inside the radical and moving horizontally. So if I want to stretch by a factor of 6, I need to plug in 1/6 x, the reciprocal of 6. All right, folks, from here you're going to try the 4 graphs at the bottom of the page and then move on to the next part of the assignment in Schoology. Thanks.